Good morning.
Good morning. How are you doing?
All right. How are you doing?
I'm good.
My God, look at that thing on your wall. So
Where?
many diagrams. And what do you do at home with those drawings?
I create them. That's all the stuff I did for Heroku and Git ages ago.
Ah, okay.
And then this is an infographic for how to organize a ClojureBridge London event.
Oh, you must share that.
I will do. I'll actually make a proper infographic rather than just a.
How do you do your infographic? What is your initial steps? How do you get started?
I draw something on.
Oh, you just okay. Oh, you just do it.
And then I use inkscape.org to actually draw the graphics. It's a scalar vector graphic package. It's quite nice.
All right. I'm on Inkscape. Is it like you download something on your machine? Is it free?
Yep, it's free. Draw freely.
Oh, very good. And only it's a browser. Oh, you got for different platforms. Oh my God.
Yes.
Lovely.
Lovely. Okay.
Is it just going to be two of us?
I think some people might be watching. If anybody is watching, then please kind of mention it in the chat. You'll be able to use the live chat to ask questions if anybody is watching. I think we had a few people last week watching. If not, then I've got plenty of stuff to talk about anyway. So
yeah. Oh, well, by the way, REPL IT is back up again. I don't know who runs it.
Yeah. Yeah, software happens, doesn't it?
Yeah. Well, it probably just did just before the study group started, right? So.
Oh, there we go. Yeah, there we go. Oh, I can watch me watching myself broadcast. Yes.
That's going to lead to a lot of mirror screens, or what do you call that? Screens and screens.
Yeah, I'm still working out the most optimal way of doing this. But I've got two screens, so I'm kind of putting all the stuff that I will display. So when I do screen sharing, I'll screen particular applications and so on.
Sounds good. I was playing with Clojure for like a few hours yesterday. That's the longest I've spent in a stretch on Clojure. And I still haven't been able to finish all the exercises on ClojureBridge. Forget about the new ones.
Yeah, it is a so ClojureBridge. We sit down with the students for about a day, and some will get through them all, but most of them don't. So yeah, don't be worried if you didn't get through all of them. There's quite a bit of work to do there.
No, that is true. Also, as you kept going through the questions, they all started increasing in degrees of difficulty. Like more than difficulty, like what I find with functional programming questions are they appear simple, or they appear just succinct. But then when you start to implement them, you have to really break them down to many small pieces. And coming from the what do you call it? The non-imperative world, right? Or what's the what's the other programming called? Procedural. Coming from the procedural programming world, the functional thinking takes a little bit of time to get in.
Yes, absolutely. I think that's probably the hardest aspect for existing developers. If you're actually new to coding, then you don't have that
bias
existing way of thinking. So so it's in some ways it's easier. You still need to build up a frame of reference, but you don't have an existing frame of reference to battle against.
No, absolutely.
And yes, there is a big difference between kind of procedural and functional. So I mean, most of the languages out there are actually procedural, and a lot of things have come from like C. They're all C-type languages, so C, C++, C#, Java. They're all very much in the same vein as themselves. They're procedural, and they all generally work the same way. But where functional is quite different, because you've got this focus around functions, and some languages are more declarative around that sort of thing as well. Yeah. But okay. All right. Well, I'll make a start, and I think Wilson's online. Hi, Wilson. Thanks for joining. So in this session, I was going to do. So the main thing I wanted to just talk about before we get into the code was this idea of REPL-driven development, and because I think it's quite an important aspect of Clojure. And so getting to understand, yeah, thank you. Getting to understand kind of the way you develop, like the development process, again helps assist the learning process of Clojure as well. So I did write a little article about how I do develop REPL-driven development, but I'm also going to show you this. So I'm going to briefly talk about it, then show you how to actually do this, and going through the ClojureBridge exercises, and we can discuss kind of interesting aspects of Clojure as we go along in that way. And then I'm going to briefly mention some of the tooling that we've got, just so that you can choose, if you haven't already installed a Clojure editor, then just some choices that I think would be quite good for you to look at, and then yeah, we'll just set up some homework for the next session. So localhost 400. Oh, there it is. And I've updated the study. I've broken this. Oh, I've broken this. That's what's gone wrong. I've broken my website. There we go. So I've updated the study guide, but I've broken it, so it's not pushed yet. So it'll have some links in of what we're covering today, and the links to the exercises as well. But let's just briefly go through this REPL-driven development. So the REPL. So this is an acronym. So REPL stands for Read, Evaluate, Print, and Loop, which is essentially how Clojure evaluates the code. So you write some code, and then you get your editor or your REPL to evaluate it. So first of all, it reads the code, which is the R. So it reads the code in. Clojure's already a data structure. It's already an AST, so it doesn't really need to do much. But if it comes across a macro in Clojure, which is kind of like a really nice templating language that's inside Clojure, then it will expand the macro into normal Clojure code, and then all the code then is ready to be evaluated. And evaluation is where it actually compiles it into like whatever it needs to for the host operating, for the host language, for the host environment. So if we're running on the JVM, then the evaluator is going to read the code and turn it into Java bytecode. If we're on the JavaScript platform, then it's going to read the code and turn it into JavaScript. And then print is going to display the results of evaluating the code. So you can evaluate just a single expression, or you can evaluate continually a program. So when you're running a program, it's continually evaluating aspects of Clojure. It's continually evaluating different expressions and function calls. And then loop is obviously when it's going back around again. So if there's more calls, then it will go around to the next call and the next call and the next call and so on. And so the main point of this really is that it all happens pretty much instantaneously. So with a lot of languages, you'll sit there, and if you want to know if it works, then you'll fire up your compiler or debugger, compile the code, and then execute it. And that might take a few seconds. It might take a little bit longer. With Clojure, it's happening straight away. You're evaluating code, and you get the results pretty much straight away, especially when you're developing. So you would select an expression, you would evaluate it, and you'd see exactly what it does. So it's a great way to kind of understand what your code does, because you can pull it apart expression by expression. You can just evaluate a single part of the code base and see what happens. So it just makes it easier and more fun, and gives you a better understanding of what you're actually doing with the code as you're writing it. So I always run a REPL. Since I start working with Clojure, I just run a REPL, have it REPL running all the time. I also write a design journal, which is something that I kind of add to this whole kind of idea of REPL-driven development, where I kind of make notes underneath of all the examples of how I've actually built the application. So there's an example here. So this is the code. It's fairly well kind of organized and structured. I'm not going to go through all this yet. But then I've got REPL experiments, which are just simple. This is my journal, which is just simple kind of little snippets of Clojure I can evaluate just to kind of see what they do, see if it's the right kind of design choices. So here I'm kind of trying to figure out what the representation of a board looks like. So I've got a vector of vectors and the hash plus. The hash underscore is just a comment. So I'm commenting out. It's not going to interfere with the rest of the code when it runs. And then I can here I just kind of decided, well, rather than actually hard code it, I can just generate that kind of data structure and play around with it, and then use some functions to see if it's the right data structure I want, and play around with it, and so on and so on. So it gives somebody else or even myself, when I come back to this, a way to kind of understand how I got to this finished part, this finished code. Because I mean, any code could be quite dense. You kind of lose the design thinking as you're building it, and it's something that you would do in the REPL. So when you're actually developing and evolving your design, then it's good to kind of keep at least the kind of important steps and important decisions you've got as a REPL experiments or design journal. And you don't have to keep this in the source code. You could actually put this into an overall design document if you want. I quite like it in the REPL because then you can just play with it. If you have live design journal, design document, then obviously you can play around with the code in that as well. And then there's a few other tools you can use with the REPL to be able to kind of maintain the quality of the code. So I use Jocker. You might see this when we go through the examples. And this is just a linter that tells me if I've done any little typos, any errors. And there's a really interesting tool which I kind of run afterwards, after I've done some coding, which will analyze the Clojure and tell me whether there's better idioms or suggest other alternative idioms, ways of writing parts of my Clojure code for me as well. And just because we're doing REPL-driven development doesn't mean we ignore test-driven development. We can do it. I quite like doing them together, so I'll kind of do a mixture of writing tests and playing around with the REPL. And I'll always want to, because I'm always going to create a test suite around the public API of my namespace. Just at the very least to prevent regressions, but also to kind of like help support and define what the API of that namespace is. And so yeah, sometimes I'll play around with the REPL first and then get an idea about what I want to do, but I'll fairly soon be writing tests as well to support what I'm learning and to test my assumptions of the design as well. And you can obviously fit CI and continuous integration into that as well. So let's have a look at that in action. Is there any questions on that so far? I'm just going to switch over to my editor. Oh, I've got some. Okay, I will add some links about how to install Jocker. I'll add them to the install guide. Oops. We're getting a bit of feedback there from Santos. Let me. Oh, he's gone again. Yeah, if you're in a loud place, then please enter a question in the chat. Yeah, we seem to have two chats. There's a chat in the Hangouts and there's a chat in the public watch thing. So I'll try and remember to keep an eye out for both of those. Okay, I'm just going to switch over to my editor now. Unfortunately, there's no option to share my second screen, so I have to switch between different editors. So there's Emacs. I'm using Emacs. It's a very popular editor on. It's a very popular editor for Clojure development, but you don't have to use it. There are other editors out there as well. Let me see, where are we? I'm going to go to 9. There we go. So let's make this a little bit bigger. Space ZX+++. So I've got some code here. This is all the exercises from ClojureBridge. Depending on how time goes, we'll go through most of these. I'll probably go through the first ones quite quickly. Is that big enough code size? Does it look big enough? It looks a bit small on there. I'm going to make it a little bit bigger. There we go. Cool.
Yeah, it's good.
Okay, excellent stuff. Thank you. And so at the moment, if you can see down at the bottom here, I've got, this is a file name. It's doing Clojure mode, so it's doing that. We've got all the syntax highlighting for Clojure, but we're not running an actual REPL as yet. So I can actually get my editor to run that for me. Which is just comma quote in there. So it's going to start a REPL. Actually, it's calling out to Leiningen, which is the build tool I'm using for the project. So I created the project just using line new and then Clojure through code. And it started a REPL. There we go. And it doesn't open a REPL window by default in this one, but I can show you what that is. If we do SS. So here we've just got a REPL window. I'm just going to move that to a more convenient place. To the side, there we go. And I'll make that a little bit bigger too. Oops, that's smaller. There we go. So this is just giving me a prompt. So you can actually code in the REPL. So this is like doing, if you're using lining and build tool, you can just use line REPL on the command line. This is the same thing. And I can go in and write some very simple Clojure code. And off we go. And then I can just evaluate that. And I'll get the result 6. So I'm adding 1, 2, 3 together, and I get 6 symbols. I don't actually use the REPL very much directly because I can do the same thing. I can evaluate code that I've already written that I write in the source file of Clojure. So obviously, if I'm writing things in the REPL, I've got the history, but it's not going to. When I close the REPL, then it's going to lose all that code. So I don't actually want that. So I'm going to close that down for a second. Oh, all fingers and thumbs this morning. So this is just Clojure code, and I can go in and evaluate this, and it gives me a result in line. So the addition of all these numbers together, this is the result. I can also evaluate this, so it prints out a little comment underneath as well. So that's quite useful if I want to keep it. If I just do the normal evaluation, then as soon as I move the cursor away, it'll get rid of it. So you've got it usually works the same thing on most Clojure editors. Okay. I'm just going to check if there's any. No, there isn't any. Okay, there we go. Oh, there we go. Right, so let's go through very quickly the Clojure bridge exercises. So some of the first ones are just to really get you comfortable with calling functions and working with numbers. So here we're calling a function called plus, and Clojure is quite flexible in the naming of things. So I think you can you can give a name to a function of anything so long as it doesn't start with a hash, because that means something else. So plus is just plus, and plus is a function rather than an operator, so you can give it lots of arguments and you don't need to worry about operator precedence rules like you do in other languages. And you can create, obviously there's two there's two values of 22 in here, so we can write this slightly differently. We can add, we can pass an argument that's actually a function as well. So all these arguments are numbers or integer numbers, and then this argument is actually a function. That works because functions are first class, and when we evaluate this function, we're going to return a value. So we always get a value back from a function, as long as that function is correctly written in Clojure, then it will always return a function, always return a value. Sometimes that value might actually be nil, but nil is also a legal value as well. And so this gives the same results as the previous one. And if we want to find the average, then what we're doing is we're wrapping this addition function call with another function. So again, we're using this function, this inner function, as an argument to the divide function. So we're going to divide the result of this expression of this function call with this value. And again, we can evaluate that. And interestingly enough, you won't quite get the same with this in the ClojureBridge REPL in the web page, because that's a ClojureScript REPL. And ClojureScript, the underlying JavaScript doesn't support this ratio type. This 163/5 is actually a value. It's not a calculation. It's a value called a ratio type. So this allows us to keep the value without losing any of the precision. Because obviously, if we divide 5 by 163, then it's going to give us a particular precision, a particular number of decimal points, and we can force that if we wanted to by just doing by using a specific decimal number. This will have a default type of a float in Clojure, so therefore we'll generate a float type when we evaluate this. There we go. So that calculates it. So this, in this case, we only get 0.6. So we wouldn't lose any evaluation. If we did 22/7, which is roughly pi, then obviously pi is a very long number. So we might want to kind of vary the precisions that we use for pi in different contexts. So we can use a ratio to delay that decision about what precision we keep that value in. And so rather than specifying how many languages there are, we can, if we've got like hundreds of languages that we include, we can use the count function. I think I've got that wrong, actually. Yes, there we go. My linter is telling me I made a typo. There we go. So one of the nice things about an editor is you can do structural editing. So I've pressed the open bracket and it's created a closing bracket for me, so I don't forget to do that. And then I can what's called slurp. So imagine you're drinking a very thick milkshake. You slurp in the values into the expression. So now I've got a properly formed Clojure expression there. And so now I can evaluate it and hopefully it works. Obviously, I forgot to test that one. Oops, what have I done wrong there? Something. I may come back to this one if I've broken it. Oops, no, sorry. There's something wrong with my count. I'm not sure why. I'll come back to that one. Interesting. Oh, it's saying there. What's wrong with that? Oh, sorry. Yes. Oops. So does anybody know why this is an issue? So we've got a list here, and so obviously just as a reminder, the one rule that we have for lists is that the first element is always going to be a function call, and there's no function called 10. We can't call it, so it's causing an error. We can actually escape. We can actually override that rule and just say to Clojure, actually, we just want to treat this list as data. So we can use the little quote mark, or there's also a quote function that we can use as well, but typically you would use the quote mark to denote that. And this, as you see, my linter is now happy. It's not complaining anymore. Now I can evaluate this function there. Obviously, that was completely intentional. There we go. So I hope that makes sense. And then obviously we're doing some more calculations here, converting between times and numbers. So we've got 2 hours, so 60 seconds in an hour. So that's going to give us the number of seconds in an hour. And then we're just going to add 25 to that result. And then we can also like times it by 60, times that result by 60 to get the time in seconds if we wanted to as well. These are quite interesting functions. Quote and rem can show kind of the diversity of functions you can get inside inside the Clojure core language. So if we've got 428 seconds, how many minutes is that? And we could probably work it out ourselves. It's not too difficult. But if we use quote, it will divide 428 by 60 and just give us the whole number part of it. So 8 into 428 goes 7 times. But it doesn't give us the decimal point. So we don't know what the remainder is. How do we work out the remainder? Oh, here's a handy function called rem. So we can evaluate that. So after we've divided 428 by 60, there's 8 more seconds left, or 8 more minutes left. And so we can just pull out parts of that data as we need to. And I think that's very much a theme of Clojure. We can actually pull out the parts of information, the parts of the data we want. And a lot of the Clojure stuff you do is about manipulating data and data structures. Use quote, yeah, right. Thank you very much. And strings are fairly simple. If you come from Java, then you probably are quite comfortable with these strings already. Some of the functions might be slightly different. But we can use str, which will join strings together. So it'll just give us a combination of that. And obviously it's not just strings, we can also put in numbers in there as well. And it will still work because it'll convert them to a string. So it's kind of doing the similar kind of thing to toString in Java. So it's quite flexible. And there are so string is essentially a very simple collection of characters. And so some of the functions that you use in Clojure will end up returning characters, so that there are specific Clojure string functions that we have that make sure that we're always returning a string when we're dealing with strings. So there's this library called Clojure.string. So most of the functions are in that we start off with are in Clojure.core, which is the namespace, the library that we use, and that's all the functions of Clojure. Clojure core, like the standard functions. Clojure.string is kind of like a close cousin to that, which just has functions specifically for dealing with manipulating strings. So here we've got this includes, and so because Clojure.string is not part of Clojure core, we need to specifically give the full name of that function. So this is so we could so the string this would be Clojure.core / string. So that's its fully qualified name. So if we didn't already have Clojure.core included in our project, then we'd have to give it its full name. So this is what we're doing with string. There is a way to kind of add this to the namespace that we'll cover in another session, and then you could just use the includes function name. So this is essentially the directory, the path that it's in. So so in the actual source code for this, there's a Clojure folder and a string folder, and inside the string there's a Clojure folder and then a string .clj file, and then in that file there's a definition for this includes function. And so now we're just checking to see whether the brown argument is inside the string argument, which it is. It's true. Another little thing to notice is that this includes has a question mark. The question mark itself doesn't do anything in Clojure. It's not a specific thing, but convention is that you put a question mark on anything that's going to return a true or a false, a Boolean value, essentially. So it just is a nice way to kind of, it just gives you a little bit more info when you're actually reading the Clojure code. And we've got spelling mistakes, so we're just doing a very simple sudo spell checker. So we realize we want to replace over with over, and so again we can do that very easily. So each of these are a returning Clojure string as a result, and so we don't have to worry about converting them back to characters. I think I've already covered that. Oh yes, one other thing. So Clojure projects also have when they're on the JVM, they also have all the kind of methods, and static methods and all the objects you want to create that are defined inside java.lang. So anything that's underneath java.lang you can use inside a Clojure project as well. And we'll do, I think there's some examples from last week which show some Java interoperability. Any questions so far? What we got? Let's have a look. No. Oh, yes, there's a question from, yeah. Oh, yeah, I did notice that spelling mistake. Yes, thank you. I'll fix that later. And okay, so we've looked at, so these are kind of simple values. So we've got numbers and strings, simple values. We've kind of also touched briefly on collections. We'll look at those in a bit more detail. And we're looking at assignments. So assignment's quite interesting. So essentially assignment is really what we call binding a symbol to a value. So in this case, we've got a symbol here, a name, essentially. And we can kind of, these are quite flexible, what we can use for symbol names. And we're basically saying we can use Jenny Loves as a way to point to this value that we're using, which is a string of what Jenny loves. So if we evaluate that, so we're actually giving now a Clojure through code, ClojureBridge exercises, Jenny Loves. We're adding that name, that symbol, to our current namespace. And so when we do, so we can actually type in Jenny Loves, and it's auto-completing for me because it's in the namespace. And I can evaluate that value, and I should get the string. There we go. So I can use a name, a symbol name, as a placeholder for the data that it represents. So if you're going to use data, a data structure many times throughout your code, then obviously you can define a name for it, and you only have to type the name, not the full data structure all over and over again. So here we're defining mangoes, oranges, defining fruits. So we can also, as well as defining a specific value, we can define a like complex value, so actually a function to generate a value. So here we're adding the value of mangoes and oranges together. So we're using the symbol names to represent the values. And we can also represent the result as well. So here we're taking those things that we've already defined and we're dividing them by 2. And then again, I can just evaluate the name and be the results. Oops, the right button. There we go. Yeah, so there's 16 fruit altogether, and divide by 2. Then we've got an average of 8 fruit. So rather than doing multiple defs, it's more common to actually define a map. So a hash map, a key value pair data structure with the values here. And then we can do, we can just pull those fruit out by using a get function. So we can get from fruit stock, we can get the value that's represented by mangoes. and that will give us value 4. And obviously we can have a nested map, and we'll show some examples of maps a little bit later on as well. So this is kind of how you would normally do it when you're like building production systems. You would kind of organize logically your defs into a map or a data structure of some kind, and just to group them together, and then you would run functions over this data structure. That's typically a way to do Clojure design. So we've seen some examples of collections. Vectors is a very simple collection. You can put anything into a vector. You can put in a string, anything that's legal. You can put in anything that's legal Clojure code. You can put into a vector. You can even put in a function call in here as well. And that's all kind of legal. So you don't have to worry about types. Clojure will manage all those types for you. It's a nice kind of aspect of the dynamic nature of Clojure. Obviously, when you can evaluate a vector, and it'll just return the vector itself, because it's just a value. A vector has an index. So 9 is at index 0.0, 2 is at index 0.1, etc., etc., etc. So we can go in and pull out things by its index. So at position at index 3, there's the value 4. So that's index 0, 1, 2, 3. So we get the value 4. It's kind of the difference between so the difference between a vector and a list is that kind of list is a linked list. So you would have to go through each element in the list to be able to pull out the value, whereas with a vector you can jump straight to any position in there. So you've got random access in kind of consistent time through a vector. We often use sequences, this idea of sequences over collections. So this is like an abstract way of thinking about collections. So we don't care about what kind of, whether it's a list or a vector. And so we just pull out values. And so common ways to pull out values is using these sequence functions. So we got first, second, last, and rest. So in the example here, we've got this string, and we want to pull out so the third value from here. For example, we could get the first by just calling first. We could get the second, obviously, by calling second, but there's no third. So we could actually get the rest first. So if we first get the rest of the this vector, the values in the vector, it would actually drop the first one. And then we would be able to get the first and then second element in that new vector that we've created. So if we just evaluate rest, is the right one? So if we evaluate the string, let's evaluate the rest. So we're just evaluating the rest function here. So then we're getting full of presents that you are always dreamed of having. So we've dropped the birthdays are from that result. So then when we get the second, we get the right one. So if we do, so we get presents when we just get the second value. And the first and rest things are a one way to do very simple iteration over a collection. So if we get the first value and then loop around our algorithm by sending the rest of the data back to ourselves, we can basically do the same behavior over and over again on each of the elements that are inside a collection. And we'll see that, and we do that in a lot of functions. A lot of functions do that under the covers for us, but we can also do that explicitly for ourselves as well. And we started talking about, we did assignments a little bit later. So if we use def, we can use the global, it's using for global assignment. Here we're using let for local assignment as well. So here we're just creating a local symbol name. So rest of strings is going to point to the result of this rest call on the collection. So again, it's going to drop birthdays are and just return a collection with everything else. And then I can use that on, I can use the second function on rest of strings in here. So within this let expression, I can use rest of strings, but once I'm out of there, then rest strings no longer exists. It's only its scope is the let expression itself. So it's a handy way of creating local names. Again, these aren't local variables because they don't vary. They're local names because we're binding a name to an immutable value. So that's quite kind of take a little bit of time to get used to as well, and also gets time. It takes time to get used to actually explaining that using the right words as well. Another exercise here was to be able to find the youngest programming language, and actually Clojure is now 11, so I do need to update this update this exercise. But so if we have our a collection of our vector collection here of programming languages, if we first sort all those values, then it'll put them in a particular order. So let's see that. So that's just the sorted function I'm calling. So it's sorted them all in order, and now I can just get the first value from that. Another way to do it is to basically use the min function, which will basically go over each of these elements in turn, and just return the smallest element as well. And there are lots of, I mean, as I noticed here, there's over 600 functions to learn in the Clojure core. So there's a lot of things you can do to kind of simplify and make your code quite elegant as well. Let's see. Oh yeah, it's just doing some comparison. Oh yeah, comparison of vectors. So vectors, when you compare vectors, then it's comparing the values. So so these things are. This is true. This is false because it's got different values. These got the same values but in different order. So that's false. And you can also compare strings. And an interesting thing is you can compare lists and vectors, because it treats, in this case, it's treating them both as sequences. So it doesn't actually care about the data structures themselves. It cares about the values that they contain, and the values are the same, and then they're in the same order. So as far as Clojure is concerned, the values are exactly the same. It doesn't matter that one's in a list and one's in a vector. And then maps. Let's see. No questions? No. Okay. So maps, we've got, I like maps actually. I tend to use maps a little bit more than vectors because you can do, you can create more meaningful data structures. So here we're defining, I guess this is a data structure that represents a person, and we've got key value pairs and the keys here. So this is a key and this is a value. So the key and value is representing the first name of the person and the last name. So we could create a very simple data structure and give it a name. Let's see. So if we wanted to give this data structure a name, we could do def person or def Sally, and then we could just use Sally to represent the map as well. And if we count them, it's counting them as key value pairs. So there's actually 2 in here. There isn't 4 things in this map. There's only 2, because we have to have a key and a value. Otherwise, it's not a legal map. It will create an error. And yes, so you can. So when you write a map directly like this, you have to make sure you've got both the key and the value. And if you're generating a map, then obviously it's going to, if you don't give it the right values, it will cause an error as well. We can merge maps together. We can associate values with map, and again, we need to supply a key and a value. The keys, so the values can be anything, as can be the keys. You can even use function calls as keys. You can use strings as keys. All a key has to be is unique within the kind of level. So if it's just a single level map, if there's no nesting in it, then first I couldn't. Yeah, so first name just has to be unique. So if this was first and this was first, then it would merge them together, and it would probably put Brown over Sally. If I did first, and if I change this to first name, then that's not going to be a legal map, because they're the same. They're the same keys. I can't have the same keys in the map, which is going to cause an error. And so I can also remove things from a map just by here. I don't need to specify what the value is. I only need to specify what the key is. So this is kind of the reverse of getting something out of a map. So as we showed before, if we wanted to get from Sally, I didn't evaluate that. Oops, there we go. Let's go and evaluate Sally. There we go. And my editor, you probably can't see it, but it puts little green chevrons next to an expression when I've evaluated it, so it kind of knows I know what I've evaluated and when I've changed things. So I can get Sally, and I want to get like the last name. So I'll specify the key for the value I want to get. So this is last name. And then that will give me the results. If I want to disassociate a value, if I want to get rid of a value, then yeah, I only need to pass the key, and it will drop the key value pair from just that key. Just like last name only returns the actual value, it doesn't return the key and the value. Okay. And there's quite a few functions around that. So we see merge. A sock is adding a value to a map, and you can also update an existing map as well by using a function. So here we got an example here of we got a simple map called hello. Let's evaluate that, and then at the moment count is equal to 1. If we want to associate a different value, we can just basically override. So it's basically saying we want to change the value that count points to with 0. Oops. And so then it updates the map. But we can also do an update here. So if we do update hello world, so we've got count is equal to 1. And so if we here use update, so we're going to update the map using where the value is pointed to by count, and how we're going to update it is by incrementing, calling the increment function. So we'll pass the value that count is pointing to the increment function, get the result, and then update the map. Update the map and change this value that count is pointing to. Obviously, as map is an immutable data structure, we're not actually changing the existing map. We're just creating a new map with the same keys with just this new value added. So what does that look like? There we go. So we've got count 2, we've got words, hello. We've got a new map with that updated value in. And obviously we can do the same thing with the string as well. So here we're actually using the string function to add the comma world string to the existing hello string. You'll notice that this form is a little bit different. This expression is a little bit different. Yes, update is a macro, so it's a little bit it's slightly different kind of. There's not as many parens, not as many brackets writing here using a macro, because this will expand to the kind of the normal Clojure code form as it's read. Oh, what was that? I can't read the comments in the Hangout. They're a little bit small. Let me make that a little bit bigger. Did you say use a function call as a key? Yes, you can use a function call as a key. I think I've actually got an example of that in a minute. Oh yes, we've got Star Trek. So there we go. I've got an example. Sure. Yeah, there we go. Yeah, I'll come back to that in a second. You can also have sort of nested maps. So here I've got a map, and it's got a key of pet. But the value is actually, rather than being a simple value, it's another collection. In this case, it's another map. So if we wanted to update the pet's age, we'd have to kind of traverse through the map. So we would go to pet, and then get the value. The value of that is a map. So then we can also traverse through that, and then say, oh, okay, the value is 5. Let's update that and return the new map with the new value in. So rather than using update a couple of times or getting the nested map and updating that, we can use update in, which is a variation of update. And in this case, it's allowing us to define a path to the key value pair that we want to update. So we walk through the map, we go through to pet, we go through to age, and then we can take that value and apply the plus function with the value. And we get a new age for our cat because it's the cat's birthday. Yay! Oh, I got something wrong there. I didn't evaluate my cat. So in this error, it's saying that it can't resolve the symbol Star Trek cat because I forgot to go in and evaluate it. So if I go in and evaluate that first, and then boom. So it's the error messages are kind of useful most of the time. There's a few times when you get some weird stack traces and they're not very useful. In Clojure 10, we're improving the how useful the error messages actually are. It does take a little bit of practice to kind of get to read some of those, but it's usually the first few lines that kind of tell you what's actually going on. Okay. Then yes, so we can also, so normally when you're getting values, you can use the get expression. So here we want to get for the map the key first name. We'll get last name as well. So we can use any key we want, but we can also use the key as a function as well. And this only works when the key is a keyword, so when it's got the colon in front of it. So we can now pull in, we can simplify, or we can have a shorter expression just by using first name and then the map. So the key and then the actual map itself. That will give us the value. And we can also use the map in the same way as well. And so suggested a bit of code there. Let's copy and paste the code that Manny has put in there. So what's wrong with that? Oh yes, that's interesting. You can't. You don't need the key. You're adding a keyword to a function. That's why you're getting the error. If you do that, that should work, I think. Should it work? Interesting. I don't know. Yeah, it goes. And then if we do. Yeah, there you go. that works. You just yeah, the colon is only when you're defining a keyword. So I could have I could use a map like this to give you a better example. So I could do a string first name, and then a value of string. So the first name is still the key. It's just not a keyword. So I can't use this form of expression to get the value because it's not a keyword. It's not used. It doesn't have the colon in front of it for the key. I can still use it in this form. So I can still do. Let's go in and do space. Space. Okay, stop that in. So oops. We've got a map, and it's got a string as a key and a string as a key as the value. And I can go in and do first name. Should work if I can type. Boom. There we are. So I could use the map as a function call with any argument, but if I want going to use the key as the function call with the map as an argument, then that key has to be a keyword. That's the kind of difference there. So normally I would use get and get in because it's clearer. If I'm doing an inline anonymous function, then I might use this form because it's simpler and it's kind of easier to read. We'll see some examples of those in a minute. Ooh, we're already at an hour there as well. It is an interesting result. Yes, there we go. We can play around with filters. So there's lots of things you can do. I mean, filter is just one neat way of kind of processing a neat way of processing a collection. So here we can do something simple. We're just using odd as a function, and filter is going to take odd and apply it to each of these values in turn, and only return the things that it's only going to return the elements that return true when we apply the function odd to them. So if we give 1 to the function odd, then it's going to return true. So filter is going to keep that in its pocket and say, okay, I'll keep hold of that and I'll return it when we're finished going through the collection. 2 is not odd, so I'm going to drop that. 3 is odd, so I'm going to keep that. 4 is odd. 4 is not odd, so I'm not going to keep that. So when we evaluate that, it's going to return 1 and 3. So we can use the Clojure core functions. We can use any functions we define. We can define a function in line here. This is what we've done. So this is our little anonymous function we've defined in line. And so what it does basically is it's going to go through and look to see which of the elements in the collection match this string called as contains we. And only return those. So that filters out everything else that isn't we, and then we can do that the other way around and filter out everything that is not we. So we've got this not equals function instead. So basically what this is doing is filter is going to take each value in turn from the collection. So it's going to take R and it's going to pass it to this function. So that R then becomes represented by word as the argument. And then we're going to take word and put it into this expression. So we're going to call not equals, and then 2 arguments are we, and then the R string that we've passed in that's represented by word. And we'll repeat and repeat until we get to the end of the collection. And then once the filter is at the end of the collection, then we finish and return the results we've got. And we can also do a short form of this function as well. So here we're essentially defining a function, but we're not defining. We could put in a name in here as well, but we don't need it in this context. And we could call the function by a name. because we're like calling it inline, and we're not going to refer to it anywhere else in the code, we don't need to give it a name. And there's also like a shorter form of this as well, which is hash before the list. So this is basically exactly the same code as this expression. But we're instead of for the argument, we're using this percent sign to represent the argument that we're passing in. So this would be R that we're passing in first, and then this percent would be we on the second run, and there, then the third run, and so on and so on. So this is kind of a simpler form. It's a little bit strange when you're first looking at things, but it's something that's fairly easy to get used to, I hope. There we go. And this is idea of kind of first-class functions, so you can use functions as arguments to other functions. We've already seen functions as part of data. So functions are data. Data is data. Everything's data. But then data can also have behavior. So the first thing in the map, first thing in this list so this list contains data, but the first thing is the function call to the function map. So there's this idea of homoiconicity. So we're representing data and behavior in the same kind of language. We don't have different syntax for different things. So here we're mapping even over our collection. It's going to return a collection of results. So we know which things are true, which things are false, and so on. So map and reduce are very common functions that we use to be able to apply behavior to a collection. And here we're going to count how many things are in there. So it's returning a collection of numbers that represent the count of each of these strings. And so map is returning a collection of results that we're applying. With reduce, we're going to apply a function that's going to reduce down the collection into a single value, typically. So if we reduce the values 30, 60 by 90, how we're reducing them is by using this plus function. So we want to reduce them by adding them all up together and getting a single value. We can do other things like this. But yeah, we can do that on strings as well as numbers as well. There we go. Yeah, so the comment from in the chat was that yeah, the short form of the function is quite nice and simple. It can take a little bit of time to get used to, but it can reduce the kind of complexity of reading the code. It does potentially make it a little bit more converse, but after you've seen it quite a few times, then it actually becomes fairly natural to do that as well. And you can actually also can do positioning. So if you've got multiple arguments, you can do %1, %2, and so on. And they don't have to be in order as well. So it's quite flexible way of doing things. And to kind of wrap up this kind of map reduce thing, we've got this idea of map reduce sandwich. Actually, I'm just going to switch back to a visual now. Oops, where's my browser? There we go. Share that. Okay, and then I have to change that on the my screen as well, so I can see it. So in the ClojureBridge study guide, whoops, where have I gone? There it is. There we go. I've got this map reduce sandwich exercise. So this is kind of a visual way of thinking what map and reduce are doing. So map, I'm going to map a function over these ingredients to basically represent kind of the act of slicing them all up into slicing the ingredients up so I can actually put them into a sandwich. So I'm slicing the bread so I can put fillings in, and then slicing all the vegetables up to put them into the sandwich. And then I'm reducing over the ingredients to actually make one or more sandwiches. So that's kind of the visual way of thinking about map and reduce. I found it quite useful for thinking about map and reduce and how to which to use and when. So let's just switch back to my editor. Not the right one. No, that's the wrong one. There we go. So I've got some raw ingredients here. Interesting. That's a bit delayed. Yes, I've got some raw ingredients here, and so evaluate that. So this represents all the ingredients that are going to make up my sandwich. I've defined a function, so I've got defining a function called prepare. It's going to take an argument called all ingredients. In this case, this argument is going to be a collection. And I'm going to use the map with my own function, and I'm going to take each ingredient in turn from the all ingredients vector, and I'm going to use a string sided ingredient. Have I got that right? Yeah, I'm not sure if I defined that right. Yeah.
Sliced, you want to say, right? Not slided.
Slice. Oh yeah, slice. Yeah, there we go. That's why. Thank you very much. That's better. I knew there was something wrong. Sometimes you just can't see something that's right in front of your face. There we go.
The spell checker is telling you the spelling's incorrect.
Yes, I'm too focused on my Clojure. There we go. Thank you for that assistance. There we go. Cats come in. Yes, so we're going to add slice to the ingredients and do that over the whole ingredients. So that's defined that function. So when we pull prepare with the raw ingredients, so the raw ingredients being our all our ingredients, then we get oh, I put that in the wrong place. That's why. There we go. Yes, that makes sense now. So I'm just going to slurp ingredient in there because it was in the wrong place. Again, the nice thing about structural editing is it makes sure that you don't have to kind of delete and retype things or paste things in. You can just move parts of your code around. So we might do more of a section on that in the near future as well. Now if I reevaluate that and then call that, then we should get sliced bread, sliced cucumber, sliced pepper, etc., etc. Now I want to make the sandwich, and all I'm doing to make the sandwich is just basically putting in a comma in between each of the ingredients, each of the sliced ingredients, and then I'm just going to call this function with inside a handy little UI, which is my string here. I'm just joining that by calling make sandwich and then prepare, and that's that. The argument that I'm giving to make sandwich is prepare the raw ingredients. So let's just remind ourselves what that is. So when we call prepare raw ingredients, we get sliced bread, sliced cucumber, etc. So we're passing that result into make sandwich as an argument, and then we should get the result that we're looking for. Let's make that a bit bigger there. I forgot to evaluate. There we go. Do that. I used to do that quite a lot. There we go. There we go. So a tasty sandwich made with sliced bread, sliced cucumber, sliced pepper, etc., etc., etc. And that's my map reduce sandwich all made for you as well. There's a different problem. I'm not going to cover this now, but we'll cover the threading macro again when we get a little bit more time. But it's just a way to write things sequentially. So basically, this expression will get passed into the next expression. Oops. And if there's two arguments, if there's two heads on here, each expression will get passed in to the last place in this expression. So it's where these three commas are. So this will be where this vector goes. Then we'll run this expression. The result of that will then go into here, and the result of that will then go into here. So it's just a more sequential way of doing it. Some people find this easier to read. Some people find it more complicated. There's another version that just has a single head, and you would put these in. You would put the vector in this location instead. So there's a slight alternative, but essentially it's going to generate the same code. So when you read this code in, it will actually just generate these kind of functions I've got here as well. So this is the kind of Lisp, the standard kind of Lisp way of writing things, but you've got the option in some situations. This is quite nice to kind of put them all together. And you can also comment some of these things out as well. So if I didn't want to interpose a comma in between everything, I could just comment these things out, and it would run all the other. So the result of this function, this expression, will get passed to here, and this one will be skipped. So sometimes it can be quite useful for debugging what your code is doing. Everybody's still here, so I'm just going to continue. I've only got like maybe five minutes more to go through. So this is just again using map to take some values from our vector. We're going to split each name, each string. We've got first name, last name. We're going to split each string by this regular expression. So this is the form for doing a regular expression. So you can kind of Google regular expressions and then just put them into this form. So the hash and then the double quotes. Here we've just got a blank space that represents a blank space. So we can split all the values in students because we're mapping this function over each one of the students in turn. And I didn't evaluate students, did I? No, I didn't. No, there we go. Oops. What have we done? Yeah, there we go. Yes, so let's evaluate students. And there we go. Boom. And so now instead of 2 strings, I've got 4 strings. Well, I've got two vectors each with 2 strings in as well. And to make that look nicer, I can flatten those as well. Well, it just puts them into a single level of a collection. So rather than having a list of 2 vectors and each vector has got 2 strings in, it basically flattens the whole data structure in, and I get a collection of 4 strings. And so what I want to do is try and kind of munge like 2 people's names together. So I can codify the split function. So again, it's just doing this Clojure string split function. It just takes a string as a name. So we would need to map that over our collection. And I can just jumble names onto Kara. Sakar. There we go. So I can jumble names here, and I'm just using local names to kind of pull out the first of names, the second of names, and then so I'm getting so the first of names would be John Stevenson, second name would be Sakar, and then I get the first name by splitting the first person up there. So I pass John Stevenson to the name split function, and then just get the first name of that. So I'd get John, and then the second person I'm getting I'm passing Manisaka over there to name splits, and I'm getting the second name from Mani, so Saka, and then I just use this to join them together. I think conditionals is pretty much the last one. So we can do, so we've got a condition we want to put in there. So common like to use if for a simple condition. So if I want to check whether it's like a number is equal to 1, then the first thing, so it's kind of, I should probably explain this a little bit more in detail. So we've got an if, and we have some kind of condition. And then if the condition is true, we do the first expression, and if it's false, we would do the second expression. It's false. That's kind of pseudo code I've just written there, so I'll just comment that out. So for this, we defined a function called position. It's going to take a number. If condition is true, so if number is going to be equal to 1, then we're going to call this expression, this string number. So basically, it's converting from 1 to first and 2 to second, except we haven't quite got that far yet. And so if we evaluate this expression, then we call position 1, we get first. If we call position 2, which isn't equal to 1, then we're going to get a different result. So it's a very simple way to put a simple condition on there. This is a Clojure expression, so as long as whatever you want to include in here, as long as it's returning either true or false, or you could also sometimes get it to return nil as well. Nil will act as false in this situation as well. And then you can kind of just decide what you're going to do about that situation. And you don't have to provide a false thing, a false result. So you can just provide a true result based on the condition. And then if it's false, it'll just return nil as a value. Then if you've got multiple ones, so obviously if we've got like 2, 3, 4, we want like first, second, third, fourth, then we can use cons, so we can have multiple conditions. And so if we evaluate this, third and fourth and so on, so it allows us to, and here we've got a catch-all. So actually, yeah, it's like from 4th to 20th, they're all ending in th, so we can kind of do the first 20 quite easily that way. And so here we're just setting up a cons. If this condition is true, then return this value. If this condition is true, then return value, and so on and so on. And once it gets the value, then it's just going to return that and go back to and return the result. So here's an example of doing the temperature in Celsius. So we're going to pass in 2 arguments, temperature and scale. If the scale equals Celsius, we're just going to return it back again, so we don't need to convert anything. If the scale is Fahrenheit, then we'll convert it with this this calculation. Same with Kelvin. And if you pass an unknown scale, then we're just going to send you a friendly, hopefully friendly error message as well. So now we can just do, oh, oops, oh, I didn't evaluate. Yeah, there we go. Oops, I pressed the wrong button there. There we go. Yeah, so 32 is 00 in Fahrenheit. There we go. So a very simple way to create a temperature calculator, temperature converter. And there was a question, sliced, interposed, concatenate. I'll come back to interpose in a second because I didn't see the question until now, sorry. I'll just do iterate, which is the last section, and then just go back to the interpose thing. So iterate is sometimes referred to as list comprehension when you're doing with for. So an example here, we're going to create a 3 a three-tumbler combination lock. So a very simple lock. We could type in all the ranges of 0 to 9, all the numbers that we're going to use. So we can have like 0, 0, 0 as a combination, 1, 2, 3 as a combination, etc., etc. So rather than typing in all those numbers, we can use range 10 to generate numbers for us. So that'll generate 0 to 9. So we're using we're creating 3 tumblers for our lock. So it's like it's a three-digit lock. And then we're just returning a vector of the results by combining them all together. So we get all the kind of combinations there. We can print that a little bit better. Print that. Oops. Oh, sorry, press the wrong place. There we go. Yeah. So we got all the combinations here forever and ever. It's only printed in my editor. It will stop after it creates 100 results, just so it doesn't blow up the editor. But it is creating all of them. And if we want to check that's the case, we can use count to see how many there is. There's 1,000 combinations. It's 10, 100, 1,000. There we go. Yep. But obviously, we might want to make the combination a little bit harder to guess, so we can actually put in some clauses, some conditions inside the for loop. So we might not want it to have a combination when any 2 numbers are the same. So if tumbler 1 and tumbler 2 are the same, then we don't want to include it. So we're basically setting up all these exclusion rules for combinations we don't want to include. And so now, if we look at this, we've got 2. Oops, wrong way. So now, yeah, so we don't have 0, 0, 0 for a start, space preferred. There we go. And yeah. And this one is giving us where they are equal. So I do get 0, 0, 0, 0, 0, 1. So yeah, this one's a bit easier to hack. I think that's all the examples from the ClojureBridge London. Again, feel free to go and play around with it. I'll go back to the what was it? He was looking for there's a question about
interpose.
Thank you. Yes, there we go. Go back to that. Interpose. There we go. Oops. Yes. So interpose is quite a nice little function. It will actually. I'll show you some. I'll jump to another file space, which is function arguments. Just a little bit bigger. Interpose again. There we go. So here I'm trying to kind of put a comma in between 2 strings that are in a collection, and so I'm using interpose in there, and it's returning. So it's going to take fish and chips, and then return another collection in there, so in between them. So it's returning 3 strings inside a collection. And there's also kind of a specific one for strings called join, which will take it will take 2 strings in a collection and then join. Well, it takes all the strings in a collection and then join them together using the comma. So the difference with this is it's just returning a string in this case. So it's basically flattening everything down to a string, whereas this is still returning a collection of all the 3 strings there. And obviously I can do that for as many strings in there as one, or any kind of values in there as well. It's just going to interpose. So basically put in another value in between each of the elements of that collection. So if I had fish, chips, and mushy peas. Oh, I haven't had mushy peas for ages. Oh, mushy peas. Right.
Go treat yourself with some, John. You deserve it.
Oh, I could do, yeah. And then if I evaluate this, boom, then we get fish, chips, and peas all with interposed all at once there with. Oh. That answers your question about interpose? Yes. What else do we have? Oh, we've got a question about Hello World 3. Let's have a look at that code in the REPL. And if somebody ever asks me anything about code, then the first thing I do is say, "Where's my REPL?" Because it's so much easier to reason about stuff. Sometimes Clojure can be a little bit dense to read. Sometimes you spend more time kind of reading it than typing it, but then I always think that's a good thing when it comes to code. So let's have a look at this. Let's go down to the bottom. Boom, boom, boom. So, oh yes. So we can use, here we can call a function, rather than writing 2 versions of the function, one that does. So if we had like, so we could have a version of Hello World, which just had this in, which just took 1 argument. Let's oh no. Off those out, and then oh, there we go. So I've had hello world. So this isn't going to take any arguments. So if I called it with an argument, then it would be an error. So if I wanted to have a function that did pretty much the same thing, but sometimes I want to call it without any arguments, and sometimes I want to call it with 1 argument, then I can write it in this form. So basically, rather than just specifying 1 fixed number of arguments, I can have, well, either no arguments or 1 argument. And when I call hello 3, Clojure is going to detect how many arguments I've passed and call the specific expression. So if I do, if we call hello, just call hello 3, then it's going to produce hello world. And then if I call it with an argument, then it's obviously going to call the other expression. 3. So you can use it is quite nice. It's adding kind of this polymorphism in respect to the number of arguments. It's not kind of dealing with the types of arguments you want. There is a different way of approaching that. But yeah, it's fairly, I've seen it quite a few times where people are defining a function, and it's so similar that yeah, you can kind of set, you can just define 1 function and define multiple different numbers of arguments, which are all get slightly different behavior.
You mean like kind of overloading the function, isn't it?
Yeah, exactly. Yeah, exactly.
Can you use values to like then make further lines, like if name is equals to this, then execute that, if name is equals to that, or is that not part of this pattern?
No, I mean, No, you can't put conditions in the arguments themselves, although if you're passing an argument, or if you're not passing, so if you're passing an argument, you could put a condition around the argument itself. So, for example, I could wrap a function around this to do one thing. So let's see. So instead of string, I could do if equals name, and then red, and then I could do something here, and then so if Fred is true, I'll print and then if it's not true, I can then do new. So you can kind of do that thing, but actually, yeah. So you're not kind of switching on the value of the argument, just the number of arguments that you're passing. I hope that answers the question.
Yep, sounds good.
Woot woot. And you can also do. Did I go on the other one? If I've got it on the other one. Oh yeah, here we go. No. I'll dig out an example, but you can. No, that doesn't do that. Let's see if we can do this in here. So as well as could do this so that how do we work? Yeah, let's get rid of that for a second. So we could call. Oops. We could do go. Oh no. Yeah. So what was this one? This is. Thinking of typing, it's not always easy. Oops, what did I do wrong there?
I think you need your fish and chips with mushy pie. Mushy peas.
Mushy peas, I think so, yes. Yeah, I've got my brain going again now, I think. There we go, that's what I was looking for. Yeah, so so rather than this one, rather than doing hello world, I could call hello again with a default name. So I could do hello, oops, hello 3, and then oops. So by default, we can call everybody Fred. So if you don't specify a name, we're just going to call you Fred, and that way you've got a default thing. So in this way, it's kind of like, I guess this is a bit like kind of doing good kind of UI design, because you're giving like a basic default to the hello world function. So if you call hello 3 without an argument, it's going to assume you're Fred, and if you're going to call it, so if I do this now, if I evaluate this, and if you call it with your actual name, then it's going to call you your actual name. So hello, my friend Fred. Oops. And then if we call it with then it's going to use that instead. And we can fix that. So string doesn't put in any spaces. You have to kind of do that yourself. So yeah, so you can kind of control and put in. It's another way. It's also kind of a way of doing defensive programming as well. So rather than having to kind of put in lots of documentation about how to use your function, if you kind of know kind of ways that people might use it, that like by not including an argument, then it will give you some default behavior as well around that. Oh, that's an hour and a half of stuff. I'm sure I've kind of killed everybody by now, but if you've got any more questions, then please let me know. I hope that's given you a good idea about what's going on with the exercises that were homework. Again, feel free to go through them. Get any more questions? If you've got more questions, we can have a look at the put them in the Slack channel. We can discuss them in more detail. And let's see what.
I'll go through the rest of the exercises, and I'll have more questions for you for next week, John.
Excellent stuff. Yeah.
I was thinking, in the meanwhile, if you already have this, you've shown us a lot of good stuff in the beginning with your IDE that you did, like your Emacs configuration and quite a few other small things like getting the results in line and even copying the results in the IDE. If you can have do you have something written up on that somewhere? Maybe we could do that offline or maybe do that online next time. That would be an interesting session.
Okay, yeah, that's a good idea. I shall do that. Yeah, the schedule of the Hangouts is open to feedback and construction. So yeah, that sounds like a good idea.
Only the simple bits. We don't need to do everything, because then we can do more bits in the next session, so that we are picking it up slowly, because it's a lot of stuff to put together as well.
Oh yes, I appreciate that. There's quite a lot of stuff there. There's so in the development tools, there's 4 kind of editors we kind of recommend for the ClojureBridge approach. So there's Atom Editor, there's Visual Studio Code, there's Emacs, which is what I find is the easiest way to use Emacs, and there's IntelliJ as well. Which I've kind of used. It's like friends at work have used that with us, and those are quite good. I mainly use Emacs myself, but if people want to kind of know more about Atom and other things, we can have a session on those as well. In the Emacs session, there's also a book I'm writing, so I'm going to do a quick plug for that. So this is Emacs with Clojure development, and this covers most of. Hopefully, this will cover everything that you want to do with Clojure in a kind of simple way, from like REPL-driven development and so on. So I'm going to add some more examples and some videos in here of what this does, and how to go through evaluating Clojure and so on. So there'll be some examples here we can go through in the weeks. But if you want a quick peek, then feel free to go and have a look at this practicalli.github.io. I'll put this in the chat if I can find the chat. There we go. Oops. Oh, I didn't want to do that. Yeah, you can go and have a kind of get an idea about what's possible. That's the wrong chat. That's the let's put it in this chat. And I'll put that in the Slack group as well. Yeah, because there's a lot of things around structural editing in here, which is quite useful. And you can do this in most of the editors as well. There's if you just want to see somebody doing amazing things without explaining them in a lot of detail, just to get a sense of what it is, there's also Parens of the Dead, which is just watching somebody building a game bit by bit. It's like simple kind of card pattern matching game, but it's using it's using structural editing and showing you. It gives you some hints about what he's doing, but it's quite an interesting just to watch somebody and how somebody's building a Clojure system together. Okay, thank you very much for joining us, and I'll hopefully see you next week. And this video will be online pretty much straight away, and I'll put in the details of everything in the Slack channel. Thank you very much for watching, and see you next
John.
time. Thank you. Thanks, Bunny. Bye.
Bye. Don't forget your fish and chips.
Yeah. Cool. Thank you. Bye.
Bye.
Boom.